gathered here for a design thinking based discussion on BJT biasing. So the problem statement here is that we are considering a smart irrigation system where we make use of moisture sensor, right? So in that moisture sensor, which is made up of analog circuits, which is all made up of BJT. In such type of devices, due to the variations in the temperature, the sensor accuracy will get affected. So there would be a unwanted trigger of the water supply to the plants. So this would damage the plant as well as water will be wasted. So we are here to find out a better solution in BJT biasing technique such that without addition of any extra devices we can compensate for the temperatures. And we are going to make use of design thinking technique in finding the solution. So we all know that design thinking is a way of problem solving by considering the user needs for an innovative solution. It is a human centric approach and there are 5 stages. Stage 1 is empathy, stage 2 is define, 3 is ideate, 4 is a prototype and 5 is testing. So apply these 5 stages and find out a better solution. So I'll give you 5 to 10 minutes, you can discuss and give me a solution. So hope you have completed your discussion. You can start providing solution now. Yes.
Let me explain about the empathize part. First, we have to understand what the user needs. We have to first identify the problem of the user. So here, our user is mainly focused on a farmer and engineering for irrigation engineering. So like that, mainly farmers are affected because the drip irrigation system, the sensor is affected by temperature. By varying temperature at night, it causes a lot of water waste and it consumes more electrics. So it's a waste of cost. The engineers cannot identify the problems because they are pre-building it. So the sensor fault cannot be changed by the engineer because it is mainly used in rural sites. So the farmers need it to the cost efficiency like that. So it cannot be used like with AI and all. So farmers have actually lost trust in it. So we are going to use it with our BJT transistor. So the next part will be explained.
Okay. So I'm going to discuss about the defined part. So in this defined part, how can we stabilize the usage of BJT in an remote sensor in order in which exposed to extreme weather conditions such as high uh, rainy seasons as well as summer season. So in order to avoid that, how can we track the data usage in a low cost as well as cost effectiveness?
And we clearly understand what the problem statement is. And actually, in unstable amplifier, due to temperature changes, we need solution which is based on affordable and simple and low power. So let me consider we using software adjusted reviews. First of all, these ideas suitable for digital components, but we are using analog components. So this idea wouldn't work. So now we are using operational amplifiers, but this is stable and precise, but it is expensive. So we use more BJTs in our circuit. So that will be good, but this wouldn't work in rural fields. So now we are using adding thermistors or temperatures sensors which help to sense the temperatures according to the environment. So from this, what we thought it should be reliable for farmers. so that wouldn't mean extra maintenance. So now we're using collector to base current, which is connecting the circuit collector to base. So this increase the collector current. So from that it reduces the base current, and this is keep everything stable. So from we choose the idea which is collector to base current. So this will be affordable, simple, and also low power.
Kiva said, um, we are going to be using the collector to base circuit for our problem statement. So the prototype part will be like it's nothing but simply connecting the resistor from the collector to base. So when we connect the resistor there, it will automatically adjust itself whenever the temperature changes. So let me just talk about how it actually works. So whenever the temperature increases, the transistor tends to get more heat and it absorbs heat. So it tends to get more voltage. So when it happens, the IC current tends to increase. And when IC increases, the collector voltage starts to increase as well. So when the collector current increases, it automatically passes the current to the base voltage. So here the base will get lower. So the resistor which we've added here will compensate any increase in the IC. So that's why we are going with this method, that is the collector to base circuit.
And the next part is testing part. Based upon the real-time example, we have a moisturizer sensor reading it here throughout the stable day and night, and we have trigger any amplified graph, and the farmers are responsible to report the condition in this forming, and we have the power consumption is unchanged. We have no uses of additional components in this.
Thus, by applying design thinking method, we have found a better solution to compensate the temperature, that is collector to base biasing is found to be a good solution. So thank you all.
Thank you.